In this video, we'll learn how to balance chemical equations. First, let's talk about the conservation of matter. The law of conservation of matter states that in a closed system, the amount of matter always stays constant. Although it can change forms, there is always the same amount of matter before and after a chemical reaction. That means that in a reaction between acetic acid and sodium bicarbonate, also known as vinegar and baking soda, the same amount of material exists before and after the reaction, it just changed form. So, what does that mean for us as chemists? We represent reactions by using a chemical equation. The chemical equation shows all of the materials involved in the smallest possible unit of a reaction. That includes the reactants, or the compounds that you start with, and the products, or the compounds that you end up with. Remember, the law of conservation of matter says that we have to end up with the same amount of material as we started with. This means that our chemical equation must be balanced. What does it mean when an equation is balanced? You can think of an equation as a seesaw with the reactants on one end and the products on the other. If one side is heavier, it will fall and the seesaw will no longer be balanced. Both sides need to have an equal weight to balance the seesaw. Likewise, the products and reactants need to have an equal weight in order to balance the equation. We do this by carefully counting atoms. To balance our equation, we need to count how many of each element there are on each side. In this reaction, the reactants have 1 sodium, 3 carbons, 5 oxygens, and 5 hydrogens. Now we look at the products. When we count the elements, we find 1 sodium, 3 carbons, 5 oxygens, and 5 hydrogens. When we compare both sides, we can see that the counts are the same, so this equation is balanced. The atoms shifted around and changed their arrangements, but all the same atoms exist after the reaction as existed before. We got lucky, and this equation was already balanced. But what happens if you have an equation that isn't already balanced? Let's look at a really simple example. This is the equation for the reaction between hydrogen and oxygen gases to form water. Let's count the atoms. On the reactant side, we have 2 hydrogens and 2 oxygens. On the products, we have 2 hydrogens and 1 oxygen. When we compare the two sides, we find that, they're not balanced. To fix it, we'll need to add some coefficients. Let's look at the products. We know that we need 2 oxygens because there are 2 on the reactant side. It can be tempting to add a subscript onto the oxygen. However, that is incorrect. When you change part of the formula for a compound, you change the identity of the compound. H2O2 is not water, it is hydrogen peroxide. So what can we do? We can add a coefficient to the entire compound. Now we have 2 water molecules being made for every 1 hydrogen gas and 1 oxygen gas molecule. We now have 4 hydrogens and 2 oxygens. Note that the coefficient applies to all the atoms in the compound. The equation still isn't balanced. Now we have 4 hydrogens in the products and only 2 in the reactants. This is easily fixed with another coefficient. Now our counts match and the equation is balanced. This chemical equation shows that for every 2 molecules of hydrogen gas and 1 molecule of oxygen gas, 2 water molecules are produced. Chemists use these ratios to decide how much reactant to use in order to achieve a specific amount of product. Using coefficients, you can now balance any chemical equation.